Hello, I welcome you all to this another interesting screencast. And the problem reads: determine the moment of inertia of the shaded area about the x-axis as well as the y-axis. This problem is coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. So, moment of inertia of an area, also called area moment of inertia. It is also called second moment of area. It has several uses within science and engineering. In mechanical and structural engineering, we use moment of inertia to calculate or for deflection calculations of beams, buckling load calculations of columns, and so many other applications within mechanical and structural engineering. Mathematically, moment of inertia is defined as about the x-axis we have I sub x equal to integral of y squared dA, and moment of inertia about the y-axis y sub y is equal to integral of x squared dA. So moment of inertia of an area is a geometric property of an area or a shape, such as the cross-section of the beam, which describes how the area is distributed around and about an axis. An axis where you want to find the moment of inertia of an area. Let's dive into this particular problem quickly and solve these two problems, moment of inertia of an area about the x and y axis. So for the first one, let's find moment of inertia about the x axis. We are going to draw a differential area which is going to be parallel to the axis of interest. This makes the work a little bit easier so that we avoid using the parallel axis theorem. So moment of inertia about the x-axis, I'll draw a strip like this. This strip will have thickness dy, and this strip intersects the curve at x, y. And then we have this whole length here of this strip, x, and then we have this height here, as y. Okay, and therefore our dA, small area for this strip, is equal to x dx, right? Okay, and then the function that governs our curve is y cubed equal to x squared. Making x subject to a formula, we are going to have y to the power 3 divided by 2. Moment of inertia about the x-axis is integral of y squared dA. Replacing our dA, we have our dA here. So replacing it there, then we are going to have integral. Of course, the integration constant is from 0 to 1. Y squared. Our dA is just x dy. So we need to replace the x also here. And if we do so, then we are going to have the following expression: moment of inertia about the x-axis, integral from 0 to 1, y squared, and our x is just a y to the power 3 over 2. Okay, dy. Alright, evaluating the two values, y to the power 2 times y to the power 3 over 2. So this becomes a 4 over 2. Then a 4 plus 3. That becomes a 7/2, right? dy. And integrating this, we're going to have 7/2 plus 1, that is 9/2. So we can factor out 9/2, can factor out a 2 like so, 9/2 then divided by 9, evaluating this from 0 to 1. Right, then finally we'll have moment of inertia about the x-axis equal to 0.222 meters to the power 4. Okay, of course. So then let's move on to the next stage, which is moment of inertia or about the y-axis. So again here we are going to cut a strip that is parallel to the axis of interest. So we will have a strip like this. This strip will have thickness dx, and our curve cuts the curve here. The strip cuts the curve at x, y, and then this whole height here from the x-axis is y, and then this one there is x. Therefore, the length of our strip or the height of our strip becomes a 1 minus y, right? Great. So our dA becomes equal to 1 minus y dx, and then we have the function y cubed is equal to x squared, making y subject to formula y will be equal to x to the power 2/3. Then moment of inertia about the y-axis is equal to integral x squared dA, which is equal to integral x squared. Our dA we said is just a 1 minus y dx. So we need to replace our y here. Okay, and when we do so, we are going to have the following. Moment of inertia about the y-axis is equal to integral from 0 to 1 of x squared 1 minus x to the power 2/3 dx. Expanding that, we have moment of inertia from 0 to 1 x squared minus x squared by x to the power 2/3. So this becomes a 6/3, so 6 plus 2 is 8/3 dx. Integrating that, we have x cubed divided by 3 minus x 8/3 plus 1, that is 11/3. Alright, so this becomes a 3x 11/3 divided by 11, 0 to 1. Okay, so if we are to evaluate this, this gives us a 0.06, round off 1, right? Of course. So 0.060606 keeps on repeating, so we can round off this to the power 4. So a summary of this is moment about the x-axis is equal to what did we find? 0.222 meters to the power 4, and moment of inertia about the y-axis is 0.061 meters to the power 4. Okay, so this is about it, and I hope the video was helpful. If it was, give me a thumbs up, like my video, and continue subscribing. Bye bye, and see you in my next screencast.